Hello. Today we're going to be talking about graphing functions and their different transformations which create a family of functions. Before we do that, we're going to graph some parent functions for our families. So there are 6 graphs on this worksheet, so you'll want to find the Graphing Parent Functions worksheet. And these are graphs that you would be expected to graph from memory. So first is y equals x squared. Making a table of values is always a good place to start. So I'd start with 0. So 0 squared, 1 squared, 2 squared, 3 squared, negative 1 squared, 2 squared, and 3 squared. So my graph of a parabola is always going to start at the middle. It goes over 1 and up 1. And then it goes over 2 and up 4. Over 2 and up 4. So typically I just require these 5 points. I will go ahead and do the 9s as well to make a nice pretty graph. Next up is y cubed. So again, filling in my table of values, we have 0, 1, 8, 3 cubed is 27. Negative 1 cubed is negative 1. So unlike squared, these remain opposite. So I'm only going to graph these middle ones on this graph because the 27 is too big. You could change your scale if you wanted to. So this one's going to start at 0, 0. It's 1, 1, and 1, negative 1. So you can see why we need more points. The next one's up at 2 and 8, and negative 2, negative 8. So that is what x cubed looks like. Next is the square root of x. So square root of 0 is 0. Square root of negative values do not exist. Okay, those would be imaginary numbers and we're not graphing those. Square root of 1 is 1. Square root of 2 is an irrational number, so I'm going to skip it and be more purposeful about what I plug in. So rather than plugging in 1, 2, 3, 4, I can skip to 4, which is going to give me 2, skip to 9, which will give me 3, and then I have nice numbers to graph. So the square root is going to start at the origin, goes up 1 over 1, then we go to 4 up at 2, and then we go all the way out to 9 up at 3. It is just the top half. There is no bottom half of this sideways parabola. It's just this guy here. The next function that we're going to graph is something that's probably new to you. This is not absolute value. This is called the greatest integer function. So it is the greatest integer not greater than the value that we're plugging in. So I'm going to start this with 0. So the greatest integer not greater than 0, and it may help to picture a number line, is 0. Okay, because if it's here, the greatest integer not greater than that, 1 would be greater, so 0 is our winner. At 1/2, the greatest integer not greater than 1/2 is still 0, because 1 is bigger. But as soon as we get to 1, we are 1. So all integers are themselves. It's these in-betweens that shift. So 1.33 is going to be the greatest integer not greater than that is going to be 1. 1.99 is still going to be 1. Then we jump up to 2. These will be 2. 3 will be 3. 3.1 is going to be 3, and so on. For the negative values, 0.1 is going to be right here. So the greatest integer not greater than 0.1 is negative 1. Same with negative 0.9. Same with negative 1. But as soon as I get to negative 1.2, we're past the negative 1 on the number line. So now negative 2 is the greatest integer, not greater than that. 2.5 is going to be negative 3, and so on. So for this graph, I'm going to start with the integers, and I'm going to do a dot on all of the integer values. Okay, then let's start at 0. So we said 1/2 is at 0. all of these decimals are going to be at 0 up to 0.9999999. So to show that I'm getting as close to 1 as possible without actually reaching it, we're going to draw an open dot. Then we jump up to 1, and then we're going to have a horizontal bar to an open dot. And the graph will continue like that. Next is the rational function 1 over x. So I'm going to start at 0, and 1 over 0 is undefined. Okay, 1 over 1 is going to be 1. 1 over 2 is going to be 1/2, 1/3, and so on. Okay, so there's something happening between 0 and 1. So to illustrate that, I've got some fractions here. So if I do 1 over 1/2, that's going to be 2. And 1 over 1/4 is going to be 4. Here, they're all going to be the same, just opposite. So this will be -1, this would be -2, -3, -4, -1/2, -1/3, and so on. So to graph this one, I'm going to start with 1, 1, and I'm going to graph these 3 numbers. So I'm going to do 1, 1, I'm going to do 2, 1/2, and I'm going to do 1/2, 2. And then here, thinking about these values, as I get closer to 0, 1/2 is at 2, 1/4 would be up at 4, and so on. So it just gets closer to the x-axis without actually realizing it. These ones are just going to keep getting smaller and smaller and smaller. So we approach that, and then we do the same on the negative side. So a -1, 1, the -2, 1/2, and a 1/2, 2. And that is 1 over x. The absolute value of x. So absolute value of 0 is 0. Positive values are themselves, and negative values are their positive counterpart. So when we graph this, we've got 0, 0, 1, 1, 2, 2, and so on. But on the negative side, -1 is 1, -2 is 2, and so on. So this graph actually looks like a V.